All right, hello and welcome. This is Unit 2E, Day 2 notes, and we have already done examples C and D in class. So if you haven't had a chance, please pause the video, try questions 1A and 1B. We're finding the inverse here. Okay, so find the inverse equation. That's the one where you have to swap x and y, solve for y, and then rename as an inverse. So pause and try those, and we'll come back together in a second. Okay, welcome back. So just a quick review on finding inverse. We want to rewrite this where all the x's become y's and all the y's become x's. From here, we're going to solve for y. So the first thing I want to do is divide by 4. We get y squared equals x over 4. And then we take the square root. So we get y equals the square root of x over the square root of 4. And we know square root of 4 is just equal to 2. So we're going to make two changes. We're going to look up at the top and we see it was originally y. So I'm going to rename as y inverse. And then I'm going to write square root of x divided by 2. All right. Have a great day. See ya. That was Mrs. Russell. Okay, so that is the first one. You can also rewrite the inverse as 1/2 times the square root of x. That also works. But either way is fine. Okay. Realize that we were able to solve pretty easily for the inverse because there was only one y and there was only one x. That arrow should be drawn over the x, sorry. And over here in problem B, the same sort of thing happens where we have one x and we have one y. And that's it, right? That's going to become important in just a minute. But for right now, I just want you to observe the fact that that's all we have, right? And we, for that reason, can swap our variables and we can solve for y. So I'll start by adding 9. And then I have y minus 2 quantity squared. So we're going to take the square root of that. And we are left with y minus 2 equals the square root of x plus 9. And last, but certainly not least, I'm going to add 2 to both sides. And I'm looking up at the top. This is originally a y. So I'm going to rename this y inverse equals x plus 9 with a plus 2 on the outside. So if you kind of do a quick check, we originally had a minus 9 on the outside. That manifested itself as a plus 9 on the inside. And then we had a minus 2 on the inside, change into a plus 2 on the outside. So quick review on inverses. And more specifically, I just kind of want to highlight the idea that right here, okay, while it might not look like a quadratic that we're used to, right, because usually we see ax squared plus bx plus c. And this is what we call a standard form of a quadratic. Okay, standard form of a quadratic. Above, right, this is called vertex form. Okay, vertex form. So a lot of the skills today in this lesson are actually converting standard form into vertex form. But we're going to do all that so we can find the inverse. So just kind of scrolling down, and more on that later, but I just wanted to let you guys know about that. For problem C, we did today in class, you can see again, we only had one x and one y. So everything got messed up royally because in this one, we had two x's. So if I were to just swap x and y, I'd be left with something that looked a little like this. Oh, sorry, not y, x. I do that all the time when I find inverses. Okay, so like I said, right, you swap the variables, but now you have two y variables, and if you had to solve for that, I think maybe some people would start doing something like this. But where do you go from there? right? Like it's hard to swap x and y and then solve for y when there's two y's available. Right? So we have one squared, one linear. It can't be done. So the answer is right here in question D. And if you didn't do this in class today, make sure you copy down example D, because example D was very special because this was a perfect square trinomial. And when it's a perfect square trinomial, you can just turn it into the binomial squared, you can swap the x and y, and you can solve no problem. You can see right here, we took x squared plus 12x plus 36, and we turned it into x plus 6 quantity squared. So the goal is going to be to rewrite the quadratic in terms of just one x and one y, aka vertex form, and then we will actually solve for the inverse by swapping x and y. So a couple examples here. We actually did number 2 in class, so you can copy that down if you need. But I am going to go through the next example. I'm going to try and color code as much as possible. So we're going to start here, and let's try number 2. Or sorry, number 1. So this wants us to find the inverse of the function by completing the square. So right now, if we swapped this, we would not have any access point to try and turn it into a perfect square trinomial using the inverse. So we're going to have to get it there first. So my suggestion is to write a little blank here for yourself. Okay? And we know that we need another blank here if we're going to add something in. So first step here is to take -2, divide it by 2. I take that middle term, divide it by 2, and that gives you your little piece of your binomial. So off to the side, of course, right? So this is really going to be y equals x minus 1 quantity squared. We're going to have a little plus something here. Oh, sorry. Color coding is going to be helpful, but it's going to take me another minute or two every once in a while. Okay, so that's going to be equal to a number. So now comes the part where we have to figure out what that constant was that should have been added. So we'll take -1 and we'll square it to make 1. And that means 1 has to be inserted on the left side and the right side. So we know that that was equal to 1. So from here, we're going to change this into a single equation with 1 equal sign. So I'm going to rewrite this and say y equals, I'm going to have to subtract that. And we're going to get x minus 1 squared minus 1. So that is the equation in what we call vertex form, right? VT. I'm just abbreviating. So now that it's in vertex form, we can swap the variables and we can solve for y. Start by adding 1. You get x plus 1 equals y minus 1 quantity squared. Take the square root of both sides. So x plus 1 over the square root equal to y minus 1. And then we'll add 1. So we get y inverse equals x plus 1 plus 1. And that's our final answer. So if I look back, we had a -1 on the inside turned into a +1 on the out, and a -1 on the outside turned into a +1 on the inside. So let me just scroll up so you can see that whole thing. And you can pause that if you need, of course. So we'll talk about questions in class. Okay, so next two actually are going to be a little bit trickier because that pesky little coefficient outside of x squared. So again, remember our first goal is going to be convert to vertex form, and then number 2 is to find the inverse. Blah, blah, blah. Okay. So I'm going to rewrite this here as y equals, and I'm going to say 4 times, and then whatever would need to be there. Oh, I'm trying to make this video shorter for you guys. I felt bad last time. Okay, and then we'll say equals, and we've got to have a little number here added. Okay, so let's try it. Let's take that coefficient of -1, right? -1 divided by 2 equals -1/2. So right away, we can do y equals 4 times x minus 1/2 squared. So if we're going to rewrite it like that, we need to make sure that we actually formed an equivalent equation. So I got to take the -1/2 and I square it, turns into 1/4. So that tells me that that 1/4 is right over here. But when we added the 1/4, we didn't just add 1/4. We added 4 times 1/4. So that's going to be 4 times 1/4. And luckily for us, that's just 1. So for right now, our job got pretty easy because of how conveniently that number multiplied back. Okay. So, right, at this point in the game, you have to relook and you have to say, okay, does that represent what was given to me originally? So you could go back right now and you could actually square this and you could subtract this 1 back and you would find that it does equal 4x squared minus 4x. So I'm going to rewrite it fully, like it's a perfect equation in vertex form with a -1 there. And now you're ready to find the inverse. So we're going to swap x and y now. X equals 4 times y minus 1/2 all squared minus 1. And the party begins. We need to add 1, and then we'll divide by 4. If you don't mind, I'm going to put both of those into one step. All right. So we have an x plus 1 being divided by 4. And right now, that whole thing is being squared. So to get y all by itself, we have to take the square root. And I'm gonna swap this to this side now. It's gonna be y minus 1/2. And that is all equal to the square root of x plus 1 over 4. And then we're going to add 1/2 back. Now again, this is going to be plus or minus. Oh, sorry, no, we're not solving. We're not solving. Just a plus. Sorry. When we find the solutions, because we're solving, that's when we use the plus or minus. But since we're just finding an equation right now, we need y inverse 1/2 plus, and see if you guys can follow that part. I took the square root of 4 right here to make it a 2. So you could leave it like that, or you could say y inverse equals 1 plus the square root of x plus 1 all over 2. Either one, that's fine. Okay? Either way, that's fine with me. So that's example 3. And of course, go back, right, review different parts of this if you need it. Also, just keep in mind, we will talk about those multipliers again. So I realize that's probably the trickiest part about these. All right, let's take a look here. Last one for the notes. We're going to let it equal y. Now, I'm going to add 15 to both sides right now. So the next line I'm going to write looks like this. Okay, so what I want you to do is write that down and then just make sure you understand where everything came from, because there was a lot of fancy footwork there. So we took the 4 out, so I divided both those by 4. I didn't want to have to worry about that 15, so I put it over to the side, because we're going to have to add more numbers to that. So that 15, we don't really need to concern ourselves with it. Just let it come for the ride as we do our calculations now. So now we've got to figure out what that middle term is going to be, right? Because the next line says something like that, right? We have to get it to a place where it looks like that. So focus on that -4. We're going to have -4 divided by 2 is -2. So it tells me x minus 2. And if we have an x minus 2, that means that the original was supposed to be a 4. So that number right there should be a 4. But when we add 4, we're not just really adding 4, we just added 16. So I know that the green 4 is what is inside the parentheses, but because of this 4 outside, you're really adding 16 when you added that little 4 on the inside. So now we've got 16 coming down, and 15 plus 16 is what, plus 31? So when I rewrite this, I'm going to subtract 31 and I'm going to put it into the real equation. It's going to look like this. So what I just wrote in green is exactly this. It's kind of crazy how it works out like that. Very quickly, I have to show this to you because it's just kind of fascinating. I'll erase it in a second, but check this out. This is going to be x squared minus 4x plus 4 all minus 31. So it's 4x squared minus 16x plus 16 minus 31. And that's 4x squared minus 16x minus 15. Oh, check it out. That's kind of cool. So now you probably believe me that those are equivalent, now that you've seen it done out. And if you want to see that out again, just press back. I think on YouTube, you just hit the arrow button, back, and it's 5 seconds each time. So if you just need a quick rewind, that's a good tip there. All right, we're ready to turn it into an inverse and call it a day on these notes. So we've got a SWIP swap happening there. Okay, swap x and y. Then we're going to have to add 31 and divide by that 4. So I'm going to combine those two steps. Hope you don't mind. So we're really close now. We're going to take the square root, both sides, and I get y minus 2 equals square root of x plus 31. Square root of 4 is just 2, so I'm going to rewrite it as a 2 in the denominator there. And we're going to add 2 to both sides. So I'm going to get y inverse equals square root of x plus 31 all over 2 plus 2. And that's the inverse. All right, so that's it for notes. What I'd like you guys to try is just turn to page number 7. Okay, just turn to page number 7. If you could just try 1 and 3 for me, right? That will help us out, and that will bring us to a good place for some solving, and we'll wrap everything up from there. Okay, so if you could come to class with page 7, numbers 1 and numbers 3. So page 7, numbers 1 and 3. And just try those two for homework. Sounds good. I won't have you guys upload it. I'll be looking for you to have those two done. And then when you come to class, the next time I see you, because this will be for both periods, so I won't say a day, but we'll finish the rest of the practice. As you can see, there's 8 yummy, tasty examples, and we'll we'll be on our way. So, all right. Hopefully this one wasn't a half an hour from the looks of it. I think it was maybe like 17, 18. So we'll see. All right. Have a great day. Talk to you soon. 20, not bad.